So in this problem, Thomas sits on a small rug on a polished wooden floor. We're going to assume the wooden floor is perfectly horizontal. The coefficient of kinetic friction then between the rug and the slippery wooden floor is only 0.12. So we're given the value of the coefficient of kinetic friction then. If Thomas weighs 650 newtons, so this right here tells us its weight. What horizontal force is needed to pull the rug and Thomas across the floor at a constant speed then? Well, the question is, what horizontal force is needed to pull? This here is asking us what is the force applied then to Thomas and the rug. And another key piece of information is constant speed, which I'll explain later on. So let's go ahead and write our givens. We're first given the coefficient of kinetic friction, which is 0.12. We're also given his weight. So his weight in this case is 650 newtons. His unknown that we need to look for is the force applied. For this problem, there's actually two more givens. But for us to see it, we're going to draw a free body diagram to see those two additional givens. So I'm going to draw this dot, and this dot will represent Thomas sitting on the rug. And I'm going to draw all the forces that act upon Thomas then. The first force that I would draw is the weight. We know that weight always points downward, so this is going to be my weight, and it is 650 newtons then. But because he's sitting on a horizontal wooden floor, that means that there's another force that acts upon Thomas and points in the opposite direction of weight. So in this case, this force is also known as the normal force. And because it's a horizontal surface, the normal force is equal to weight. So this is also going to be 650 newtons then. Next, I'm going to draw the force applied, which is our unknown. So we don't know what the value of our force applied is. And we also know that there's actually friction in this problem. And we remember that friction points in the opposite direction of the object's motion. So if the object's going to the right, that means friction has to be going to the left then. So what role does the constant speed play then? This constant speed tells you that if we add all the forces in the horizontal direction, meaning that force applied plus the force of friction, it will sum up to equal to 0 then. So in our case, the force of friction is going to equal to the applied force then. So let's go ahead and put our additional givens. We know that the normal force is 650 newtons. We also know that the force of friction is equal to the applied force. So for this problem, we know we're dealing with friction here. So we're going to use the force of friction formula. Force of friction is equal, in our case, the coefficient of kinetic friction times the normal force. But we also know that the force of friction is equal to the applied force then. So let's go ahead and rearrange the equation then. So first, I'm going to go ahead and put our force of friction. And because the force of friction is equal to the applied force, I'm going to substitute with the applied force. And because the applied forces are unknown and it's already isolated, that means I'm done with rearranging the equation then. So now with my equation, force applied is equal to the coefficient of kinetic friction times the normal force then. I'm going ahead and plug in my values then. I know the coefficient value is given to me as 0.12 times it by the normal force, which in this case, 650. I'll go ahead and multiply those two numbers. I should get 78. So that means that my force applied then is equal to 78 newtons. So now we're going to double check our answer. We learned that on the previous slide that the applied force is 78 newtons. So we're going to double check everything. First, we check our sign. In our case, it's a positive number. So that means that the force is going to our right. So which makes sense in our diagram that we drew earlier. Second, we're going to check our number. Is it too small or too big? Seems like it's about, seems correct. And finally, the last point, we want to make sure we have the correct units. Since this is a force here, you should have newtons as the unit then. And this looks like this is our correct answer.